Hi, everyone. My name is Gábor Czigléczky. I'm from Sinetiq, and I warmly welcome you to the Microservices versus Service-Oriented Architecture presentation. Let's see first what's the agenda for today. I give you a very brief introduction about myself and the topic, and there is no way to talk about these concepts without talking about the monolith as an architecture. So I will do some slides about that, and followed by I will give you an overview, then a comparison of microservices and service-oriented architecture. I try to explain these concepts and show the similarities and the differences between them. And after that, some thoughts about future trends. And let's start. So, as I said, my name is Gábor Czigléczky. I am from Hungary, and I moved to Sweden in 2023. Uh, my career paths are two parallel things. I was a teacher for 9 years, and after that, for some years, I was teaching adults as well. Um, and for the past almost 6 years now, I've been working as a software developer, and currently I'm working as a system integrator at Sinetiq, which is a tech company specializing in integration and component-based architecture, hence the topic of this presentation. And this presentation was also done in April 2025 at the UMEDEV conference. So some initial thoughts about the topic. SOA and especially microservices are very, very well-known buzzwords. Everyone is talking about that. Not everybody knows what they mean actually, or different people has different views on this topic. And they are very popular concept together with the cloud. SOA is more like a used to be a buzzword, and the industry is sort of rediscovering it. So this is why it's very interesting to see what's the difference or what are the similarities between these things. As I said, we must talk about a little bit about the monolith architecture because these concepts are often compared favorably to monolith, and I will try to explain these approaches as well. And this topic is very relevant. I brought some big companies that use either microservices or service-oriented architecture to some extent, to some degree as well. Of course, as like almost every topic in the IT industry, it's a little bit ambiguous. It depends who you ask. What does one mean by microservices and service-oriented architecture? So this presentation is a little bit about discovering how are they similar, how they differ, what are the different viewpoints on these things. I'm deliberately not going to take any sides in this debate. I just try to show you guys the concepts and especially where to use them. Are they the silver bullet I'm asking on the slide? I think you might know the answer for that. No silver bullets. So first, then let's talk about a little bit about the monolith. I think everyone who worked with software development for a longer time might have encountered at least one monolith application or monolith architecture. That means, as you can see in the figure, there's an application. I put the web in brackets because they are usually not web applications, but it's possible to have a web application. But usually it's like a traditional old style desktop application, which is not bad necessarily. But the common thing with the monolith applications is that all the services, in the example, we have the account, inventory, and shipping service. All the services are inside one application. And if the application needs a database, then it's one huge database, often not the best structured database. And the application communicates with this database. I listed some disadvantages. The first and obvious thing is that it's not really flexible. You have to retest and redeploy every time you change anything in this application. And the components are not really reusable unless you call Control C, Control V as reusability, which is not, of course. Usually, these components are very specific and very tightly integrated, so you cannot just remove it and add it to another application. And of course, for example, if you need more of the account service or the inventory service, you have to scale the entire application, not just these services. The fault tolerance is usually limited. It cannot be stated as a fact, of course, but usually one error in the application causes the whole application to crash or the functions are severely degraded. There is no way to replace components at runtime. And if you want to adopt a new technology, a new database technology, a new programming language or something like that, it's usually very, very challenging. So the industry's answer was a component-based architecture. It's like an umbrella term. In the later slides, I will try to explain what is the connection between the component-based architectures and the others. But first, let's talk about the simpler case, the microservices. So if we if you try to compare with the monolith architecture, you can see on the figure that the main concept is that we break down the application to smaller, separate services, all called microservices. These are very limited and very focused small components. And if they need, they use their own database, not a centralized database. All services are dedicated to one function, so they do something and they do it the best they can. We have one or more applications, a web applications or a mobile application or both, but of course it still can be like a bigger desktop application as well. And usually not necessarily in every case, but usually we have a new component called API Gateway, which is the main proxy connecting the services and do some other functions such as collecting metrics, authentication, authorization, transforming the data, validating the input or something. Sometimes they, especially when they have a separate web application and mobile application, they use a module called BFF, backend for front end. So you can, if you have different front ends and they work very differently and they work with very different data structures, then you can add another layer called backend for front end to transform the requests and the data between the different UI components. So this is what's the main difference and a very simple view of the microservices. I also brought some pros and cons. It can be figured quite easily that some of the disadvantages that I listed with the monolith architecture are easily solved in this setup. You can individually develop and deploy all the components. You don't have to retest everything necessarily, and you can scale the components independently. It's possible to use the best technology available for the service, so they don't have to use the same framework, the same programming language, the same database technology or model or something like that. And the services become reusable if you write them generally enough. The fault tolerance is improved. It is not 100% guaranteed that a failure is completely avoidable in this architecture, but there's a much better chance that if one component fails, then you can fix it, redeploy it, and the application is up and running again in a much shorter time frame. But it also has challenges. Of course, the development process can be more complex, especially the testing and the debugging, because all the requests they are coming through different components. Sometimes it's quite challenging to follow the request path. The deployment pipelines are more complex. Especially in cloud environments, the infrastructure costs can be much higher. And usually the main problem is the lack of standardization. So, for example, different kind of logging styles in the different components, different teams are working on the different components. They approach things differently. So many of these cons can be eliminated or mitigated by good governance and a good standardization. And sometimes it happens that the microservices architecture brings performance issues. Again, so many components, they are sending like HTTP calls or huge JSON objects between each other. Authorization on every level can slow the process down. So basically, if it's done in a smart way, most of these cons can be mitigated. This was a very brief overview of the microservices. Let's talk about the service-oriented architecture. It's a concept emerged in the late 1980s, so it's a very old concept, and it's like a way to make software components reusable, interoperable, and through service interfaces. So the service-oriented architecture is more like an integration architectural style. It's more like an enterprise-wide concept. But we will talk about this a little bit later, comparing to the microservices. Um, and I talked a lot about services already. These are reusable software components. And similarly to the microservices, I always mean the code that operates the service and the data that the service is working on together. So it's a complete discrete business function together, the code with the data. Or according to one of many definitions to the service-oriented architecture, there are four properties of a service. It's usually repeatable, a business activity with a specified outcome. It's self-contained, usually works with its own data. Um, of course, it's not 100% independent to the other components, but it operates independently. It's a black box to the users, to the consumers. They don't have to be aware how the service works internally. And of course, we can talk about system of a system. So every service can be composed of other services as well. The following slides are a little bit information heavy, so I try to be concise. Bear with me, please. Um, there are some distinct features of a service, and you can see a figure which is very common when you display a service-oriented architecture. The service has an interface which defines how to invoke the service. Usually, the developers are more interested in that. But it also has a contract which defines the nature of the service. What are the terms and conditions of using the service? What are the prerequisites, cost issues, quality of service, etc. And of course, the implementation, the code that builds the logic, which can be literally like any programming language. The service, of course, is the basic building block of service-oriented architecture, and there are some very important components here. A service provider is one that creates, maintains, and provides one or more services. And there's a service consumer, which consumes data from the provider. So it essentially requests a provider to run a specific service. And what's more common in the SOA, that there is a service registry or service discovery. It's another name for that. It's a directory somewhere in the network, so it's a network accessible, and it's a list of available services. So you can query the available services, and you can be notified if a new service has been created or if a service ceased to exist anymore. Some very important principles of the service-oriented architecture. You can see on the figures, I start with that, the granularity. The services can be fine-grained or coarse-grained, depending on the level of detail at which services are designed and implemented. So the monolith is one big chunk, as we can see. The microservices are the smallest chunks working together, and the SOA is somewhere between the two. Bigger components, but they are like smaller than the monolith. Um, the fine-grained services, they are more specialized. As we move towards the microservices architecture, we can see that the services are more specialized and performing just one simple function, but it may lead to overhead if you have so many services and so much communication between the services. The coarse grained, of course, they have like larger set of functionalities, larger blocks, as you can see in the SOA, but the disadvantage can be that they may not be as flexible or reusable. The interoperability means that different kind of technologies and platforms work together. Maybe the most important and the most heard is the decoupling, where you minimize the dependencies and improve the reusability of components. So the components are um, like you change something and it does not affect the others. And you can reuse the components and build new applications once you have some services done already. And the abstraction, it means that it can mean that you hide the complexity, and it can mean that you define like very clear interfaces, uh, limit the exposure of the sensitive information, which can be used to enhance the security of the application. And the services can be business or application services. It's the same thing, just called a little bit differently. These are the services that you usually count as services because they perform uh, specific business functions like inventory or creating bills or something like that. And there are some infrastructure services which are usually part of centrally managed component. Um, and it can have many other tasks, authorization, authentication, logging, exception handling, etc. And there's one more component which is quite common in a service-oriented architecture, not necessary in every single use case. It's called the enterprise service bus, which is a software component responsible for different kind of data transformations, um, various connectivity and messaging functions, routing. Uh, Service-oriented architectures use different communications protocol, and you need to convert between them, etc. But in the recent implementations, um, instead of the very strictly configured enterprise service bus, you can use many other technologies, REST API, SOAP, MQTT, and other uh, type of technologies. So what are the benefits of service-oriented architecture? I tried to draw a very simple um, figure, which can be compared to the others that were shown with the microservices and the monolith. Um, so the little difference here is that you have the small services, but they can share databases, or they can have uh, their own database if it's needed, or that's possible that they don't have a database at all. Um, they have either an enterprise service bus or a REST API or an MQTT bus, some kind of communication technologies that uh, like bind these components together. And you have many types of consumers, browser, web applications, or even desktop applications, mobile applications, and so forth, or other services, for example, from the cloud. Some benefits using this architecture: faster time to market means the reusability. You have an inventory service that you can use in other applications, so you can build a new application from existing services relatively quickly. You can leverage legacy functionality. It's also very important in a service-oriented architecture. You have a legacy system. I have some experience with that. Legacy system with a very convoluted database structure and very difficult to use. And you build an application that sits in top of this and expose the services, functionality, or data from these legacy systems. It's a very, very common use case for service-oriented architecture. The collaboration can be improved between the business and the IT teams if you distribute the services based on business functions. And of course, the development can be parallel. The features can be developed like in an isolated manner, independently. But of course, certain type of agreement is needed on the contracts or the data types and so on. So basically, so far, I talked about monolith and the microservices, and I tried to define SOA to some extent. Now it's time a little bit to compare, because you might have the feeling that I'm more or less talking about the same thing when I'm talking about microservices and service-oriented architecture. It's partly true, but there are some very distinct differences. For example, as an architectural style, SOA is an integration architectural style, while microservices is more like an application architectural style. And with that said, the scope is different. The microservices are more application scope, and SOA is a bigger, more enterprise-wide concept. Both can be used to break a single application into small pieces, but the service-oriented architecture can also be used, as I mentioned in the previous slide, to sit on top of a legacy application and expose data and services from existing applications. Microservices usually have very local access to the data needed, and the service-oriented architecture is more like there's a primary data source, and all applications obtain and modify the data at the primary source. And some other differences, microservices usually use like very lightweight messaging protocols. It also can be true to the service-oriented architecture, but they are more open to like more heavyweight protocols. So AMQP, MQTT, and so on. For the microservices, the granularity is definitely smaller. Specialized services, they are designed to do one thing and one thing very well. In case of SOA, there can be very small specialized services as well, but you can have larger enterprise-wide ones. And as one of my colleagues mentioned with his project, it's also possible to combine microservices and SOA, or microservices, SOA, and monolith. So you can have a service which is more like a monolith itself. Um, as for the speed and the data sharing, for the microservices that they use their own data, it also means that data duplication can happen. Um, it can be faster, but it can be challenging to synchronize all the data and use the latest and the up-to-date version of all the data all the time. The SOA is a bit easier to develop and troubleshoot, especially the larger components, but they tend to operate more slowly. Uh, and as I mentioned with the microservices, they are usually not very consistent with the governance. The more consistent they are with the governance, the better are the results, and the the closer they are to the service-oriented architecture. For the SOA, it's more like it's not an option. It's a must to have. Um, uh, some kind of data governance standards across all the services. Um, as I mentioned before, I try to define how these architectural styles are related. So component-based architectures is an umbrella term. Service-oriented architectures and microservices are uh, mostly the same thing, more or less the same thing, but they can be very different in terms of service granularity, data distribution, um, and so on. Both has a purpose of breaking down big applications into smaller, reusable components, but usually microservices they go further. Um, but service-oriented architecture is more like an enterprise-wide concept um, with high data distribution means that the applications can have multiple data sources, or they can have like a single point of truth. While the microservices are smaller components, uh, more colorful technologies, more agile development, the more utilization of the cloud systems and cloud technologies. Um, this architectural style is very popular when you have multiple teams and you can have teams organized as the architecture dictates. The service-oriented architecture um, is like a bigger gun. Some organizations or some applications they don't require such a robust communication layer or enterprise scope or that many of messaging protocols and data distribution. So the bottom line here is you have to choose between these architecture styles. You can combine them, but you have to choose wisely because there are no silver bullet, of course. One example for that is the Amazon Prime Video. They had a video quality analysis service in 2023, which was initially implemented in a microservices-based architecture. But the problem was it was a serverless monitoring tool analyzing every single frame of the videos. But it proved to be way too expensive, and there were like huge performance issues because there were many services and they were passing huge video frames between these services, which made the whole process very cumbersome and very slow. So they have decided to migrate back to a monolith-like architecture with the result of 90% reduction in operational cost. So you have to when you choose architecture, you have to think about things like that, like cost and speed concerns as well. A general guideline when to use these architectures. You can use a monolith when it's a simple application or a prototype, a single server application, or part of an application requires a monolith-like architecture, like the Prime Video example, when you would have to pass huge data chunks between the services if they are broken into smaller services. The microservices is when there is a DevOps culture and DevOps mindset in the team, very agile, using different kind of languages, frameworks, and you have the required knowledge set, cloud, the different kind of APIs, the containerization technologies, various troubleshooting techniques and tools, and so on. And with the SOA, if you have a legacy or standalone enterprise application, you want to expose a part of it or services or data from it, or you have a single application that uses multiple data source, you want very, very much reusable services, you want to share some functionality and data with the external clients or partners, and so on. Some thoughts about future trends. The microservices, they move to the containers, they move to Kubernetes and to the cloud. As you all know, the edge computing, it means that remote locations process the data at the edge of the network by a device or a local server. This is a one emerging technology as well. More emphasis on security, the use of AI with analytics, dashboards, anomaly detection, and so on. Serverless, this is a new category, function as a service, event-driven architectures, and the zero trust security model, which means that you don't trust anybody and you tighten the security checks and limit the exposure of sensitive information. For the SOA, the lines are blurring. The whole point of my presentation is that SOA and microservices are not necessarily very different, and the lines are constantly blurring between the traditional service-oriented architecture and microservices. They adopt more and more cloud-native principles, containers, AI integration. They are also shifting towards the event-driven infrastructures, and more emphasis on compliance, governance, and we can see the birth of new communication protocols that can help with the special use cases as well. So basically, this was the overview of service-oriented architecture and microservices. I try to compare them. I try to show you examples where to use, what are the advantages and disadvantages, so you can choose wisely. And should you have any more questions or comments about this topic, you can find us on the webpage, and you can reach me at this email address, or you can find me on LinkedIn as well. Thank you very much for listening. I hope it was useful, and see you in the next one. Bye-bye.